Okay, so we're going to fill in the blanks, stating the number of different roots, and as I said, we've done this already. This just has the actual blanks to put the number of ways. So there's the pinball, one way to get to the top of it, and then remember each side, there's only one way to get there. It's never going to go across horizontally or back up top. It's always going to go down. Think about gravity pulling it down. Okay. Then if you think about to get to this point here, only can come up from the top left and top right. So there's two ways there. Same with this one here, can only come up from the top left and right. So that's 3 altogether. So remember, it's the sum of the diagonals in the row above it. So 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then go. Okay. And we even talked about the other day, if you add up all of the ways to get the pinball coming out of slot, in this case, that's going to be 5 plus 6 is 11, plus 4 is 15, plus 1 is 16. Each row here actually adds up to a power of 2. Okay. In this case, that's 16. Okay. So we're going to relate that to Pascal's triangle. I'm just going to minimize this a little bit. What happened? Okay, so the above pattern can be seen as the first few rows of what's called Pascal's triangle. Listen, folks. So Pascal's triangle is named after Pascal. And so we talked about him last week in this triangle. So taking a look, first row. So why it says Alberta Education here is that some textbooks, depends on where you're reading about Pascal's triangle, they might actually call this row 0. And you'll see why in a second. In Alberta, we call it row 1. Your IB will be, I don't think they actually even ask them row. I haven't seen them do that in the IB. But if you use row 1, that would be fine. Because it's not going to be specific formulas, for example. So here, we're going to call this row 1, has 1 entry. Row 2 has 2 entries. Row 3 has 3 entries. Row 4 has 4 entries. There's lots of patterns in Pascal's triangle. So the row number tells you how many entries there are. We already talked about adding up the terms. So let's do that here. It asks you later, but let's do this all at once here because we've already talked about it. So all the terms 1, all the terms 2, 4, 8, 16, and what do you think? 32, even if you didn't look at them, based on the pattern. Your inductive reasoning, right? Power of 2, how do we show this? This would be 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th. Okay? Take a look. So if I told you I want to know the sum of the row number 10, do I need to draw that up? No. Looking at this pattern, would it be 2 to the 10 or 2 to the 9? 2 to the 9. So the exponent is 1 less than the row number, right? Row 4, exponent 0. Row 1, exponent 0. And that's why, as I said, some textbooks might use 0, call it row 0, because of that exponent being 0. Okay? So, summarize what we just said here. Notice how row 1 has 1 term, 2 has 2 terms, etc. Also notice that there's a pattern. Yeah, I didn't go through that, but each entry is the sum of the diagonals above it. Okay, so you can always get the next row by using that property. And then, so here, complete the next 2 rows. So let's just do that quickly. 1, 6, 15, 20, 15, 6, and 1. Notice the pattern within each row is symmetrical, right? So here, if there's an odd number, then the first 3 are the same as the last 3. If it's an even number, the first 3 and the last 3, or shouldn't be 3, but however many in that row. But it's symmetrical, right? So it's like a reflection of each other. Okay. So how many terms are there in row 3? 3, 6, 6, 300, 300. Might get a question like that. Right? On a diploma, they wouldn't have just that as a question, but they might say, answer, 3 properties of Pascal's triangle, and then have a code or something like that, so that they can ask you a number of questions about it.
How many properties do you know? Because I know there's way more than this.
Yeah, I mean, we're using sort of 5 properties, I guess.
What if we say something like one is really obscure, but is it correct? Do they mark that as correct?
Yeah, they're not going to ask you that on the written response. Yeah. Determine the sum of the terms. So we've done that. Write your answers. We've done that. Power of 2. We've done that. How does the exponent of the power of 2 compare to the row number? It is 1 less than the row number. So the sum of the terms in the nth row will be 2 to the n minus 1. Sum of the terms in the 10th row will be 2 to the 9. 23rd row would be 2 to the 22. Okay, now we're going to extend this. You don't want to have to draw the previous row to get the next, and so on. Just like sequences want to have a formula so that we can just go skip right to a really term really far away, right? Okay, so it says, given a portion of Pascal's triangle, it is easy to generate the next row, but what if you wanted to find a term in the 57th row? Writing out the first 56 rows would be tedious and time-consuming. The following example will demonstrate how to find the values in any given row without having to know the rows before. So let's take a look here. This is row 1. Notice what's entered here. It's combination notation 0C0, which has a value of 1. 1C0 has a value of 1, 1C1 has a value of 1. 2C0 has a value of 1, 2C1 has a value of 2, etc. So where do these come from? Or how do we know? We're using combination notation. Where do the n's come from now? So just be careful when we're talking about n, right? We're saying n is the row number, then really this notation is n minus 1, right? So sometimes you might get confused about n. We use that a lot. In any case, just think about what row number and what the first value in your combination is. So the first value in your combination is going to be 1 less than the row number. So 0, 1, 2, 3, 4, not starting at once. Then your first term in each row is going to be 1 less than the term number. So this is term 1, so that r is 0. This is term 2. We always start from the left. Term 2, 2 minus 1 is 1. Okay. Term 2, second term, subtract 1, get to your r value. We go down to something like this row. Fourth term, then the r would be 3. Fifth term, r would be 4. Okay, so it's always 1 less than the row number, 1 less than the term number. Okay, so write out the next row using combination notation. So obviously that's 5. The next would be 6C0, then 6C1, then 6C2, 6C3, 6C3, 6C4, 6C5, 6C6. You gotta have all of them. If you get to the end and only get to 6C5, you miss something. Or you get to the point where it's 6C7, you got too many, or whatever. You started not with 0, you started with 1. So every term in Pascal's triangle can be expressed as NCR. For each row of Pascal's triangle, the value of n is 1 less than the row number. Okay, so that's the n for the combination notation. Our value is 1 less than the term number. So if you wanted to find the 27th term, the value of n would be 26, and the 7th term, that would be 6. Okay, we skipped to the 9th row. Okay, so based on what we know there, your first value in here is 1 less than the row number. So if we're looking for the 9th row, we're going to have 8C, and you always start at 0. Then 8C1, 8C2, 8C3, 8C4, 8C5, and then a little space, 8C6, 8C7, 8C8. If it's the 9th row, you should have 9 terms. Count them up if you missed one. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then as numbers, I'm going to leave that for you to do. Obviously, the first and last are 1s. The second and second last are 8s. And then you can go from there. I'm not going to spend the time.
Can you just, I mean, like, since it's a sequence, you just do it, like, it's a safe space, you just use, like, sequence. Right? I mean, like, obviously, probably this is what they're looking for, right? I'm just saying.
General case.
Yeah, like, I did, like, the weird brackets, 8CR, R starting at 0.
Yeah, I guess you could, but probably we'll ask for the whole thing.
Yeah.
So.
It would be like, it's like for the 87th row. Like,
yeah, no,
I didn't need that.
We're going to do that. Okay, so the last example demonstrates how to state any given row without having to generate all the rows before it. Let's find just specific terms. So the second term in the 23rd row. So row number minus 1 is 22. Term number 2 minus 1 is 1. That one you can figure out. Don't leave it out. Okay, 11th term in the 17th row. So 17th row minus 1 is 6C. C, 11th term, that would be 10. And you can do that on your own. 47th term in the 50th row. So 50 minus 1 is 49. 47 minus 1 is 46. You can figure that out. So what are the first 3 terms in the 12th row of Pascal's triangle? So 12th row minus 1 is 11. And the first 3 terms, that means we've got to start with R being 0. Then 1, then 2. Obviously, there's more terms. We just asked for the first 3. What are the last 3 terms? In the 18th row, so we're going to have a bunch of terms here. I'm going to start from the right. So 18th row will be 17, C, 17. The last term, N and R will be exactly the same. Okay, then and 17C16, 17C15. Okay, middle term in the 25th row. How many terms in the 25th row? 25, right? Term number tells you the number of terms. So there is a middle number because that's an odd number of terms. It's the 13th term. Middle of 25 is 13. So the 13th term, 25 rows, so it would be 24, C, 12.
N minus 1, C, N minus 1. Yeah. Or that works for all. Oh, sorry. Well, that's not sorry. Not the row number.
Keep it like that.
Whatever.
Keep it like that.
The not N. It's like the row number minus 1 and row minus. You know what I mean?
Okay, so we just keep it like this. Row number minus 1, term number minus 1.
This is why I think that starting at row 0 makes it all like that.
Do it then. Up to you. Okay. So what would the middle two terms in the 38th row? So now there's an even number of them. So half of 38 is what? 19 and 19, right? 19 terms and 19 terms. So the middle two terms, that would be the 19th term and 20th term. And it's the 38th row, so that'll be 37, C, 18, and 37, C, 19. Okay. Let's do this one. Oh, I don't have a calculator up. Okay, they should be the same. The two middle terms will be the same in any row of Pascal's triangle. Oh, yeah, it's really big. Sorry. I'm not going to write it down. Not going to write it down. Okay? So for question 2, we discussed how any given term is the sum of the terms above it in the previous row. Using combinations in diagram 3, we see that the third term in row 6 is 5C2, and it's equal to the sum of the second and third terms in row 5. So it's equal to, so this is 5C2, it's equal to 4C1 plus 4C2. That's in the triangle, right? All the terms in each row. Okay, so if you are here finding how to get a particular term based on the previous row values, then we have to go into the previous row. So if we're calling this NCR, then this would be N minus 1 C R minus 1 plus N minus 1 C R. Okay. So based on this, any term in our triangle, you can get it by adding the two diagonals above it in the previous row. So if we are calling this 5n, then we've got to subtract 1 from it to get the previous row. Okay, so that's all that that's saying. Really, you're not going to use that formula so much as just coming up with the values. All right, so there's your Pascal's triangle related to the notation, the combination notation. So earlier we saw, not see, that the sum of the numbers in the nth row of Pascal's triangle was 2n minus 1. Power of 2 is 1 less than the row number. So again, it's asking you to write the sums here as a power of 2, so just quickly rewrite them. it says in the top right, how does the exponent on 2 compare to the n value when the triangle is written in combination notation like this? So how does it refer to the number of objects? The first part here, the exponent is the same. Okay? So here we're given a row in Pascal's triangle. Okay, what row is it? So take a look at the first value. It's a 7. Remember, that's always one less than the row number. So it's going to be the 8th row. State the sum of the terms. Do not go in and add them all together using the calculator. Take a look. We're going from 0, 1, 2, 3, 4, 5, 6, 7. Okay, so we've got every term in that row. You always want to check. Maybe there's a term missing. But we've got every term in that row. Okay, and so we can just use our exponent form, 2 to the 7th. Remember, the exponent is 1 less than the row number. 8th row, the sum is going to be 2 to the 7th. So what row is this one? It says, what's the sum and what row is it? Well, this first value is 10. That means it's got to be the 11th row. Okay. Take a look. Do you have every term? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You've got every term in that row. So this is going to be 2 to the 10. Next one is going to be the 10th row. This is a 9. And so 0, 1, 2, 3, 4, 5, 6, 7, 8, but it's missing C9, right? But saying that, so if we add 9 to 9, we would get 2 to the 9. Okay? So that means that this value here will equal 2 to the 9th minus 9C9, which is just 1. That is 2 to the 9th. A lot faster than adding in all of those combination notations in the calculator. Some of these terms. So 6. So it's the 7th row. Okay. See how many terms? 0, 1, 2, 3. Missing 4, 5, 6. So this is going to equal 2 to the 6th, right? It's the 7th row, so it's 2 to the 6th. That exponent matches the n value in the combinations, and then you're missing 6C4, which is 6 times 5, which is 3 times 5, which is 15, and then 2 to the 6, 64 minus 15. Okay, so then evaluate these. Notice it's summation notation. So that means if I were to start writing this out, it would be 14C0 plus 14C1 all the way to 14C14. Okay, if I were to expand that out. So that's every term. There's nothing missing going from 0 to 14 if that n value is 14. So that's going to be 2 to the 14. circle in the next one. It's starting at n equals 2 here. And notice it's using n and ends in where r is, so you have to be careful of what you're talking about or thinking about in terms of n. So first term would be 21c. Put in 2. 2 minus 1 is 1, so 21c1. Then 21c2. And then getting to the end, that's going to be putting 21 in there. So that's going to be 21c20. We subtract 1. So there's a couple of terms missing. There's 21c0 and 21c21. Both of them have the value of 1. Okay, so this is going to equal 2 to the 21 minus 1 and minus another 1. Okay, so I'll do it in 2 steps actually. Okay, so 2,097,150. Okay, so we're good. We got up to question 20. Question 21, I'm just going to leave that. That gets kids are not going to do that one. You can do these. They're basically a repeat of what we just did. And so actually, we have just finished Pascal's triangle.